This over here so keep track of the time. So folks, we need out our packet for Unit 3 opened up to those 3 pages that you were assigned for homework. You also need your reference table, pen or pencil, and a calculator. Pages 18, 19, and 22 are the 3 pages you were assigned for today. So let me come around and start checking that those 3 pages are done. I think most of you finished it in class yesterday, so this is just pretty much a formality, just to make sure they're done. No, that's right on page 18. There's 22. 18. Okay. Of course, that's my mistake. So, yeah, anytime I was just yes, no, and that was my mistake. So as soon as you pointed that out, I said, yeah. Alrighty. So let me read off the answers to you. All right. And then at the end, anything you want me to go over, I'm happy to do that. So on page 18, remember we changed this to calculate average velocities, not accelerations. So the average velocity for part A is positive 20 meters per second. In part B, it is positive 70 meters per second. And in part C, it is positive 20 meters per second. Any of those we need to go over? Yeah. I know it's frozen. I'm not showing it on the screen. I'm just reading you the answers and I'm asking you if you need me to go over any of them. Panema? Part A? Okay, so you have to get the initial velocity off the graph at 0 seconds. You read the graph at 0 seconds and it is 0 meters per second. Then read the graph at 1 second and that velocity is positive 40 meters per second. You're looking for V bar. V bar is found by doing VI plus VF and then dividing by 2. So 0 plus 40 is 40. And then you divide that in half, which is positive 20 meters per second. Okay. All right. Page 19, number 1. The acceleration is 0 meters per second squared. In number 2, it is positive 1.0 meter per second squared. In part 3, it is 0 meters per second squared. In number 4, it is negative 1.0 meters per second squared. In number 5, it is 0 meters per second squared. And number 6 is positive 1.0 meter per second squared. Those are the slopes of those lines. Emily? So number 4, I'm going to look at 5 and 13 seconds. Point 1 is at 5.0 seconds, comma, positive 3.0 meters per second. Point 2 is at 13.0 seconds, comma, negative 5.0 meters per second. The unknown is lowercase a. The equation is a equals y2 minus y1 over x2 minus x1. So now I do my substitution with units, which is negative 5.0 meters per second minus positive 3.0 meters per second, all over 13.0 seconds minus 5.0 seconds. So the numerator becomes negative 8.0 meters per second, and the denominator is 8.0 seconds. Negative 8.0 divided by 8.0 is negative 1.0 with the 2 sig figs, and that gives us a unit of meter per second or meter per second squared. I know I'm just visually saying it, but hopefully that's good enough so you can see your mistakes. Any other questions on that page? Those were all slope calculations, right? Okay, last page, 22. I'm giving you answers with 1 sig fig because the graphs only had 1 sig fig on the time axis and the velocity axes, okay? So number 1, the displacement with 1 sig fig is positive 100 meters. In number 2, the displacement is positive 90 meters. In number 3, it is positive 5 meters. In number 4, it is positive 50 meters. In number 5, it is positive 30 meters. And in number 6, it is positive 40 meters. Any questions on those? Okay. I'm sorry? Number 5. Okay. Which method did you choose to use? Area or kinematics equation? Okay, so that means you have to break that up into a triangle on the top and a rectangle on the bottom. So your givens for the rectangle would be a base of 1 second and a height of positive 20 meters per second. The triangle would have givens of a base of 1 second and a height of positive 10 meters per second. From 20 to 30 is positive 10 meters per second. So now I'm going to find the area by doing the base times the height of the rectangle plus 1/2 the base times the height of the triangle. So that would be 1 second times positive 20 meters per second plus 1/2 times 1 second times positive 10 meters per second. And again, I have to round to 1 sig fig because of the sig figs on the graph, which means I end up rounding to positive 30 meters. If you got positive 25 meters, you just didn't pay attention to the sig figs. You got to round it to positive 30. Round it up. Does that make sense? Okay. Anything else you'd like to ask? Purnima? Okay. Which method did you choose to use? The area method or the kinematics equation method? Are you using V bar equals D over T, or are you using the area of a triangle to do this? You didn't use either. Those are the only 2 ways to do it. That's why you're having a problem. So I'm going to use the area equation. I got to find the area of that, what is shaded in. The base is 1 second. You should have listed that as a given, that the base is 1 second. And the height is positive 10 meters per second. You need to find the displacement, which equals the area of that triangle, which is found by doing 1/2 the base times the height. So that would be 1/2 of 1 second times positive 10 meters per second, which gives you an answer with the 1 sig fig of positive 5 meters. That's question 3. Anything else, Dakari? Which method did you choose to use? Area. Okay, so you have to break it up into a triangle at the top and a rectangle on the bottom. The rectangle would have givens of a base of 2 seconds and a height of positive 10 meters per second. The triangle should have a base of 2 seconds and a height of positive 20 meters per second. Do you have that correct? Okay, so the area will be found. The displacement is your unknown, which will be found by finding the total area, which is the base times the height of the rectangle, plus 1/2 the base times the height of the triangle. So you should be doing in your substitution step 2 seconds times positive 10 meters per second plus 1/2 of 2 seconds times positive 20 meters per second. Since all our givens have only 1 sig fig, you're going to round to 1 sig fig, which gives you positive 40 meters at the end. Anything else? All right, let's take our quiz. You may use that homework to help you. You will need your reference table and calculator. You can use that space on those pages for scrap paper as well. The quiz for Unit 3D should now be posted in the Google Classroom. Here it is. Please go ahead and take this quiz now for Unit 3D. Good luck. Once your quiz is done, you can put away your Chromebooks. And once your Chromebook is away, pull out your notebook, please. They're just testings. Shh. All right, looks like we're almost done. So take a look at what's assigned up here. On Monday, we're going to take a quiz on what we're learning today. We're going to work on this today and tomorrow. It's actually a 3-period lesson. So Unit 3E will be quizzed on Monday, but the entire unit will be tested on Wednesday. As you know, I've mentioned that to you previously. So you want to be working on your test corrections for Unit 2. Remember, those are due by Tuesday. If you have them, you just stick them in the bin over there, the top blue bin over there. And the review assignment, which you certainly should be working on tonight, at least a little bit, pages 29 through 42 in the Unit 3 packet. Okay, so you knew about that previously as well. That's not new. So just make sure you're working on that because all of those pages are due on Tuesday. We'll take a class period on Tuesday to review for the test, which is Wednesday. We only have 2 weeks left in the marking period, which means you also want to make sure that if you are planning to do any lab corrections, that you get those done ASAP. If there are paper lab, like Lab 1 and Lab 5 were, you need to find a time to come in and meet with me to do it. When you have a free period or after school or before school, let me know you're going to come down and do it. So that way I can make sure I pull it out for you to do. The online ones, which were all the other labs, you just resubmit them in Google Classroom. Don't resolve the comments that I made. Just leave it. Just resubmit it. I'll check it and give you the points back. Okay. Any questions? All righty. So then let's move into the next section of notes. Our last section of the unit is now about problem solving with accelerated motion. And this is heavy on the reference table, folks. You need your reference table out and open in front of you to page 6. Page 6. And what we're going to be learning and then practicing for the duration of our time today and tomorrow is how to solve these problems using the guess check method. But now we're going to have lots of equations available to us to use, which means the guess check method will become very important to make sure we're doing this correctly. So what will I be quizzing you on? Obviously, using the equations that we're going to see today to describe and represent motion of objects, both objects that are accelerating and those that are not. And then I'm going to ask you to actually solve problems using the guess and check method. And these problems will involve lots of variables, including time, displacement, velocities, and accelerations. So let's review the problem solving method. Do you remember what the guess method includes? What's the first step in the guess method? List your givens. There's one more slide after this. So I'm reviewing the steps with you, which I think you already know. List your givens. What's after that? List the unknown. Then what? Yep. Then you're going to search, and this is where it's going to be a little harder today because you don't just have one equation to pick from or 2 equations to pick from. You're going to have a total of 5 equations to look at. Figure out which equation you're going to use using the givens and the unknown in a list. What's after that? Not always. Yeah, algebraic manipulation. Okay, if it is not isolated for the variable that you want to find, you have to move it around first. Then what can you do? Now you can do your substitution with units. And then what's the final step? Solve it. Getting an answer with proper units, sig figs, and if what you're being asked for is a vector quantity, it will also need a direction. That's right. And then what's the very, very end? The check. And that's also called dimensional analysis. To show that the units you plugged in match up with the units of your final answer. Showing how to get the units of your final answer from what you plugged in. Showing the steps. Okay? So let's now talk about what equations you have to pick from. Here are the 5 equations. So I'd like you to go to page 6 of your reference table and check off those 5 equations on the list. In order, they are V bar equals D over T, which we already checked off. Then we have our A equals change in V over T, which we already checked off. The third equation is read VF equals VI plus AT. That's new. Then we have this other one, D is VIT plus 1/2 of A times T squared. And the final one that we'll be using is VF squared equals VI squared plus 2AD. Now let's go through and make sure we have all of these checked off in the right-hand column of our reference table. So remember that D will stand for either a displacement or a distance measured in meters. T will represent the amount of time in the question, the time period measured in seconds. A stands for the acceleration of the object measured in meters per second squared. We added VI to our list previously, where VI represents the initial velocity or the velocity at the beginning of the time before the acceleration occurred. VF stands for the final velocity or the velocity after the acceleration has occurred. V bar, we talked about this one yesterday. Check that off if you have not. V bar represents the average velocity of the object during that acceleration time period, measured in meters per second. And delta V stands for the change in the velocity, which is determined by taking the final velocity and subtracting the initial velocity. All right? All that good? Okay, now we're going to just practice. So let's go to the packet and let's turn to page 23. Make sure you keep these reference tables out unless you want to memorize all those equations and so forth, which I would not recommend. I told you the notes were very brief. What are we really working on? We are working on practicing using that method to help us solve problems involving motion of objects now. And it could be accelerated motion and it could be constant velocity motion, either one. And I'm going to demonstrate how we do this with a couple of questions today with you. And then tomorrow we'll start doing this more independently. And in fact, I'll actually have you come to the board to show your solutions on the board or put them on the document camera after I put you in groups to do it. So in question number 1, it says we have a car that has a velocity. Let's change that so it's actual velocity of positive 2.0 meters per second. Notice I'm going to circle the information that I know, which is a step we learned, at time 0. And it accelerates at a rate of positive 4.0 meter per second squared for 2.5 seconds. What is its velocity at that time of 2.5 seconds? So notice I did some circling of given information and I'm underlining what I'm looking for, the velocity at time 2.5 seconds. So I'm now going to go through my givens list. These 3 values that I circled are given pieces of information. This first measurement that I circled is the velocity at time 0, which means that is the initial velocity of positive 2.0 meters per second. That's the starting velocity. This value here I see is at in meters per second squared. I know that is a unit of acceleration. So lowercase a is positive 4.0 meter per second squared. And I'm being very careful not to drop any digits because of the sig figs that will be required for my answer. This value here is in seconds. Seconds is our unit of time. So that is our lowercase t value. Now we're going to go to this unknown, the velocity at 2.5 seconds. That's the ending time. So that means I'm looking for the final velocity of this car. So here's what we now do. We go to the reference table and we're looking for the one equation in this list of 5 that includes a VI, an A, a T, and a VF. And I start at the top of the list. Well, I don't see VI or VF there. I don't see it here, but I see it here. I see the VI, the VF. There's the A and the T. So that is the equation I'm going to pick. That, and I'm going to write it. And I copy it right off the reference table. VF equals VI plus A times T. And again, I'm making sure that my plus sign looks different than the T, because otherwise I'll get confused. Which one is the T and which one's the plus sign? It is isolated for VF, so I can go right to substitution with units. So VF is equal to positive 2.0 meters per second plus positive 4.0 meter per second squared times 2.5 seconds. Now we're going to go to the calculator and we're going to do the math. 2.0 plus 4.0 times 2.5. Just do it on your calculator, get an answer. And before I write it down, I'm going to ask myself about sig figs. How many sig figs do I need for this question? 2. Does that have 2 sig figs? It does. And since what I'm asking you for is a velocity, I want to make sure I put a direction on this value. It is positive, so I'm going to put my positive sign in front. And I know velocities should be measured in meters per second, so that's the unit I'm going to add to it. Now I'm going to do my check step, and I'm going to do it right over here, the dimensional analysis. I start by rewriting the equation that I substituted into, which was the same from the reference table. VF is VI plus AT. I'm now going to change out these symbols on the right. VI was in meters per second. A was in meter per second squared. And T is in seconds. And I want to show how to get meters per second for my final answer. This second would cancel with the square, leaving me with a number of meters per second added to another number of meters per second. I don't know what the numbers are. It really doesn't matter. If I add a certain number of meters per second to another number of meters per second, I'm going to get a number of what? So this is equal to meters per second, which notice it checks. You see how that works? You remember we've done this before? All right, let's go to number 2 then. What is the displacement of a train as it is accelerated uniformly from positive 11 meters per second to positive 33 meters per second in a 20-second interval? Okay, let's go to our givens list. Notice I've got 2 velocities being given to me. One is a VI, one is a VF. Which one is the VI, the starting velocity? Pam? So VI is positive 11 meters per second. That's what you start from, which means the other one is what you are going to, the VF, positive 33 meters per second. What is the 20 seconds? It's a time, T. Now, what is our unknown letter? Displacement. Okay, so now we need to go to the reference table. Notice that in my list, I do not have any acceleration value given to me, which means I should not be using any equation that has an acceleration in it, which means there's only one equation that would work. And what is that one equation? Because it does not include an acceleration. Emily? What kind of velocity equals displacement over time? Average. And I don't have that yet in my givens list either, but we can get it pretty easily. But before I do that, we have to isolate D. What is that equation for D going to look like? Kia, can you tell me? Yep, so the V bar times the T. All right. I'm not going to show the math to get the average. You have 2 velocity values. How do you find the average of 2 velocity values, Janelle? Add them and divide by 2. So what is the average? And I'm just going to list it right here. What is the average of positive 11 and positive 33? What is it? Careful. not just 22. Positive 22, and the units? Okay. So I really have that. It's not being given to me explicitly, but I know it because I know how to find an average of two numbers. And so do you. So let's now go ahead and do our substitution with units. So the displacement is positive 22 meters per second times 20 point seconds. Now you're going to do your solve step. Go to the calculator. And we want to make sure we have calculators to do this. Otherwise, you're going to do all this math in your head. 22 times 20. You got to have how many sig figs on that answer? 2. Does that have 2 sig figs the way it's written? Sure does. It needs to be a vector, though, so we're going to put our sign on it. It remains positive because displacement is a vector. 440. And what units will we get, Kim? Meters. Now we're going to do our dimensional analysis check, but we're not going to check the one from the reference table. We're going to check the one we plugged into. Displacement is average velocity times time. What are the units of the average velocity? Jack, can you tell me? Good. And Addie, what units did we plug in for time? Okay. Caitlin, what happens now? Yeah, the seconds cancel out, leaving us with meters. And that's what we expected. That's our check. But you do have to show how it gets there. You have to show the steps on how to get there. Right, can we go on to number 3? A car starting from rest. That's a phrase that's going to give you a measurement. Accelerates uniformly at positive 6.1 meters per second squared for 7.0 seconds. How far does the car move? All right, let's think for a minute here. Starting from rest gives you a measurement, even though I didn't give you the values. I want you to think about it. If you're starting from rest, what is that telling you? Savannah, what do you think? So what is that a measurement of? When you're not moving, what is that telling you? What physics measurement do you have that's here in this list? What kind of velocity is it? We have VI, VF, V bar, and change in V. Yeah, that's your VI. So we should be listing VI, and what numerical value is it? Yeah, 0 meters per second. That's what that phrase is telling us, is that our VI is 0 meters per second. Ashley, what am I going to put with this positive 6.1 meters per second squared? What letter? A. Yeah, it's an acceleration. Purnima, what am I going to put with the 7.0 seconds? Yep, so what letter? Yeah. Now, what is the unknown letter here, Cam? D. All right. Now we have to see, using the reference table, we need a VI, an A, a T, and a D. So start at the top of the list. Well, there's no A in that. This one doesn't have the D, so that's no good. Nor does this one. There's a D in these two. But which one is the better choice? The top one or the bottom one? The top one, because that's the one that has the time. The bottom one doesn't include any time. Do you see that? So that's the equation we're going to copy and put on our sheet. D is equal to VI times T plus 1/2 of A times T squared. Now, is it isolated for D? Good. So we could go right to substitution with units. D is 0 meters per second times 7.0 seconds plus 1/2 of positive 6.1 meter per second squared times 7.0 seconds, and that quantity gets squared. Now, you do need parentheses around the 7.0 seconds. Otherwise, you've already given me a squared time value. You want to square the 7 and the seconds. Now you can go to your calculator. Do you have to type in 0 times 7 on your calculator? No, because it's going to drop out. I'm actually going to put an X through it because I know that's going to drop out. So all I'm going to focus on is on the second half of that equation. Half is the same as 0.5. I'd encourage you to type it in as 0.5 times 6.1 times 7.0 squared. I didn't need any parentheses when I went to the calculator because I don't have any units that I'm typing in. There's my calculator answer. That's not what you're going to give me as your final answer because of sig figs. How many sig figs, Josh, am I going to need on this answer? 2. Half isn't a measurement, so we don't look at that for sig figs. We just look at these 2 numbers, 2 sig figs. What am I going to round that to then, Dakari? Yeah, 150. And what units? It's a distance, meters. So we're going to say that the distance is 150 meters. No sign on it because it's a scalar. Now you have to do your check on D equals VIT plus 1/2 AT squared. What are the units, Brandon, that we had for VI? Good. Dakari, what are the units we had for T? Good. Now, let me ask you this, folks. Does a half have a unit attached to it? No, so it's not part of this checking because it doesn't have units. Only things that have units matter. Ignore it. What are the units for A, Olivia? Good. Meter per second squared. And Janelle, what are the units for T squared? T squared. S squared. Okay. What's going to happen now, Alex? Can you show me what I would do at this point? What happens in this first term?
The seconds are going to cancel out.
Yeah, so let's show that.
And then the second squares are
Okay, so what does that end up giving me? It gives me some number of meters added to another number of meters. And if I add a number of meters to a number of meters, you get number of meters. So the answer is in meters, which we expect. We don't care about any numbers. We're just looking at units. How are we doing? Make sense so far? How are we doing on time? We got time to do one more. Let's do it. Number 4. An airplane must reach a velocity of, I'll make that positive, 71 meters per second for takeoff. If the runway is 1.0 kilometer long, what must that acceleration be? How many of you have ever been on an airplane before? Okay. When you get on the airplane, is it moving? Okay, we assume you know that, which gives you a value that is not listed in the question as a given measurement. What measurement would that be giving you? A VI. The VI is 0 meters per second because the airplane isn't moving when you get on it. Okay, what does that mean this positive 71 meters per second is? Nick Rushford, can you tell me? What is this positive 71 meters per second a measurement of then? Which velocity? VF, that's the ending one, right? At the end of the acceleration. Now, what is this, Jules? The 1.0 kilometers. That's a distance, D. Now, folks, we can't work with kilometers. We need it to be in what units? Meters. Go to the front of your reference table. Remember that K is a power of 10. What power of 10 is a lowercase k? 10 to the third. So let's just swap it out. 1.0 times 10 to the 3 meters. Just swap it out because you can either write the K or you can write the 10 to the 3. We need the 10 to the 3 so I don't have the kilometers in my substitution. All right, what is the unknown letter? Caitlin, can you tell me? Yes. All right, so now we need to try to find an equation that contains those 4 letters. Do you notice time isn't in the list? There's only one equation that doesn't include a time there on page 6. Addie, do you happen to see it? Yes. VF squared equals VI squared plus 2AD. Now, is it isolated for A right now? Nope. You got to move it around for A. And I don't really care if you show me all the steps or not. I just want to know, what is that equation for A going to look like? Cam?
A equals BF squared minus BI squared over 2B.
Yes. Eventually, you won't have to think about it. You'll just be able to get there. Now we're going to do our substitution with units. So positive 71 meters per second. That quantity must get squared. Minus 0 meters per second. That must get squared. All over the quantity 2 times 1.0 times 10 to the 3 meters. Just get that substitution written down, and what we'll do tomorrow is we'll pick up with that. Okay? All right, folks, have a wonderful day, and I will see you tomorrow. If anyone needs to stop in after school for some help, I'm here. Stop in.